Thank you, Sue. Now, look, you'll have to bear with me. Usually I do presentations when I'm in a woolshed or a small town hall doing workshops and things like that, not with the screen above me. So I'm going to be talking about variable rate application and be focusing on application of fertilisers, which, look, the technology's been around for a long, long time in the States and Europe have been using it for a long time. But look, in Tassie, it's only recently been adopted. It's probably the last probably 4 years, and I think that it's been happening. I remember the first jobs I was involved in. It could have been the first one in Tassie. Was I don't know if anyone knows Richard Webster, but he'd been ticking around with variable rate irrigation for some time, and he'd started getting those systems right. And he started asking the questions, well, why can't we start doing this with nutrients? So we started going down that track and started soil mapping a paddock, and eventually managed to put some variable rate maps together, put them in the spreader, and it was pretty good to see that happening. It was a bit of for us it was a big thing, and then since then it really has taken off. I think everyone's got to know that there's contractors around that have got variable rate application in their spreaders. There's also that technology is available in drills. So I want to go through what information you can use to create these variable rate maps, but also how to put that into action. So variable rate application is basically it's the ability to be able to apply nutrients to a paddock at a known rate, at a known spot, and it's all based around trying to target known variances within the field. It's a case of everyone knows they've got variation within the field, so it's a matter of trying to work out where that variation is. And as I said before, there's a lot of technology now that's come out that's got variable rate application. So most, spreaders, drills, sprayers, it's almost coming out. It's an optional extra, and I think down the track it's going to be coming out as standard. It's just been it's a bit like RTK now. It's a standard thing. Sorry, it's a bit hard to see that screen up there so often. So it's basically, by implementing VRA, you've got the opportunity to reduce input costs. You've also got the opportunity to target areas to improve yields. But the key thing is you need to have variation within the paddock to make it pay. If there's no variation, there's no point in going down this track. So why do we have yield, or why is there yield potential differences in the paddock? And in most cases, in all cases, it's primarily due to changes in soil type within the paddock. If you all know, when you look at a Google image with that, and also as you know, as you actually work in the fields, that there's big changes in soil texture across the paddock. Topography has a lot to play. You've also got the soil type, which is the parent, what the parent materials come from, sandy soils, also mafic soils. So there's a whole range of things that influence the yield potential and the variance within the paddock. There's a whole raft of other things that come into play, and it's like aspect, there's drainage, irrigation, and there's also things like even livestock. The nutrient transfer, particularly in dairying systems, from one part of the paddock to another part of the paddock, congregating around troughs and gateways. And there's also, as many farmers would do, they'd sit at the kitchen table with an aerial photo map with their coffee cup and start drawing circles around where can we put the next pivot. And where those pivots go often overlay over square paddocks. And there's some big variances already by including those paddocks within that circle. So things like soil structure, base fertility, and a whole raft of other things start to come into play. So that's where you start getting variance within the paddock. So how do we get this information so that we can actually start to get a handle on where these variances are within the paddock? So one of the first, if you want to go down this track, one of the easiest ways of doing it is actually starting to create your own soil zone maps within the paddock. And a lot of, I suppose, when the VRI technology came out, that's one of the first things that would happen. People would start to draw zones around different soil types within the paddock. Same thing you can do with a very basic soil map. You can go around, start distinguishing where the boundaries are, and I wouldn't get too hung up on being too exact with it. But if you can start to identify those different zones, EM maps is also handy to be able to help identify those zones, but you can do it without it, but it's just a very good tool to help. It's basically identify the boundaries of those zones. So once you've identified where those zones are, you can then start to target those zones and individually soil test those zones, and that's going to start to give you a bit of a background information of how those, particularly the nutrient status of those soils, and start to get a bit. And you've got to go out there and ground truth this, so you've got to go out there and dig holes, feel the soil, touch it, get a bit of an idea of the soil structure and what's happening, and that's going to start to give you a bit of a basis for starting to create your own variable rate maps. Once you've got that information, then you can start feeding that information into creating your own VRA maps, which then you can start putting into, depending on what you're using, drills or spreaders or what have you. The next step is, if you want to go that one step further, you can start to, as Tim was talking about, start doing some grid sampling, where you can actually start to take samples that are known positions in a grid pattern throughout the paddock. There's a number of ways this can be done. You can have points in the paddock in the known spaces. You can go around and sample on those points. You can also have square patterns in the paddock where you do transects from one square to the next. Once you get that information together, then you can start to build a map, a nutrient map, and it's quite surprising when they come back, because it does. It's interesting when you sit down with the farmer and actually go through these maps. There's some things that they can explain. That's a recently cleared bit of bush there, or this is that, or they can explain it very quickly. But there's also some things within the paddock they can't explain. And so this is where this grid sampling is good to highlight those areas. It is a more costly form of getting this data, but it does show up those areas, things you can't see. The map I've got up there was for a new horticulture development, and which is particularly for new development sites where you've got to start looking at putting capital applications of lime and also phosphorus. It's quite critical that you have these sort of maps if you want to do your budget, but also try and create a consistent, particularly phosphorus and pH across the site. So here's some more grid sampling maps. So this is a project that I was involved in with Bill Koching and Peter Redditz. We're basically the part of the project we're looking at nutrient transfer within the paddock and irrigated dairy or dairy pasture systems, because we knew that there was nutrient transfer within the paddock. Particularly around where the congregation of cattle with stock with gateways. So to go about that, it was a standard grid sampling method. We went through to the sampling, and this is what the maps came back like. And this one's a phosphorus map, so it shows you there are two. Obviously, it's a centre pivot. The dairy's in the middle, but you can see the pointy end of the wedges there, which is the purple, is where the phosphorus levels are quite high, very high, extreme. And then on the bottom paddock there, you can actually see we've got the blue area where the phosphorus levels are quite low. Now, when you look at this map, those purple areas and the red areas are areas where P levels are very extreme. It doesn't matter how much phosphorus you put on those areas, you're not going to get any more yield out of those areas because they're well above the optimum level. But where you start getting those green areas, they're the optimum levels. So we want to really keep those there, maintain those. So what we do is we put on a maintenance application of phosphorus on those areas. On the areas where the blue areas indicates areas where the phosphorus levels are, in this case it was well below the optimum level. So they're areas where phosphorus is going to be a limiting factor to pasture production. So once you've got this information, then you can strategically start to target those areas. Those blue areas, we've got limited production, so we can start to put on some capital applications of phosphorus to lift those levels up to where the critical level is, so that phosphorus is no longer a limiting factor. But on those purple areas and red areas, it doesn't matter how much phosphorus you put on, we're not going to get any more growth out of it, so we may as well cut that out of this. We won't put anything on there. So when you go through that process and you start zoning up those areas, then you can produce on the right-hand side there is what we call the variable rate map. And so that's basically strategically targeting the nutrient to apply to those areas to match the yield potential. So in this case, there was some capital application of P needed to go on that bottom paddock there. The rest of it was pretty much maintenance at varying rates. So it's a relatively easy thing to do. Then you actually email to the spreader or on a USB stick, put it in the spreader, and then they can go. So this is the same property, but this is looking at potassium. And same thing, you can go through the whole process of doing a potassium map and then work out what potassium needs to go on. Look, in terms of, as part of this product, we tested, this project we tested potassium, and it was quite interesting. There's quite a variance, just like phosphorus, across all sites. The problem is, though, that when the spreader goes out, this is where you start to get these hurdles with, I suppose, variable rate application, and when you're talking about more than one nutrient, is that we can put the phosphorus on the variable rate, we can also put the potassium on, but we've got 2 trips to go over the paddock. We're not quite there yet. I think that down the track that, and probably, Tim, you might have seen in the States, there might have been some variable rate blending technology of granular fertilisers, but that's where we're going to head if we really want to sort of take this technology and use it. I know that in drills and many other in the States, they're doing variable rate blending when they're using liquids, so they can actually vary the rate of phosphorus and potassium, other nutrients, as they're drilling. So it's so that's where we're going to head down the track, I think. The other useful tool, as Tim has highlighted, is also look at NDVI images, which is it's an instant snapshot. You can get this, as he said, every second day you can get that an image down here. So it gives you an instant snapshot of where there are yield potential differences within the paddock. And this is a great tool to actually work out, well, what can I do with these yield potentials? Can I improve yield? And it's a case with these systems, you've always got to go out and ground truth. You've actually got to go out in the field, find exactly what's driving that, and then start zoning it up and start making decisions about, can I actually influence this yield? With the NDVI, you're limited to at later crop stages, really limited to nitrogen and to a degree potassium, as you look at nutrients that will influence yield. Phosphorus is not really going to do much at the later crop stages. With this image here, you'll see that there's, hopefully you can see there's a line. There are 2 black lines at the bottom of the circle there. The very bottom one, you can see that there's a colour change there. Now this is where we did a trial, a nitrogen trial. So the crop was planted as a blanket, planted across the whole crop, with the starter read and also with the phosphorus and also potassium. But when we did our nitrogen budget, we worked out how much nitrogen was required based on doing deep end tests. And at the bottom line there, what we did is we put on half this nitrogen rate. So there was about 2 or 3 nitrogen applications after planting. So we put those rates on at half. And just above that, there's a black line, we put it on at twice as much. So you can see there that the half rate definitely had a big difference on yield potential based on the NDVI. But the black line above it, there was no difference at all by putting twice as much on. So it meant that, for us, it meant that our yield, the nitrogen budget was pretty much spot on, so we're quite happy with that. So it's a really good idea with this technology and sensor technology like this to be able to do your own trials within the paddock. You'll soon get to know what's going to work and what's not. Particularly if someone's coming to sell you something, some flash liquid's going to do this. Give it a go, spray a bit on the paddock and start to look and see if there's any differences. If there's not, you can start asking questions, is it worth, pursuing this? So yield maps, as we've seen before in the previous slides, are a fantastic tool to work out. It's proofs in the pudding once the yield map comes out. So this is a really good idea to start matching your inputs with yield potential within the paddock. So in most cases there's software around where you can actually start to define zones of similar tonnages. And the best thing you can do once you define those zones is, as we talked about, is start applying some financials to those zones, and that'll very quickly give you a bit of an idea where you're making, where you're not making money. So on the areas where you're not making money, you need to start asking the question, well, what's driving that? What's the cause? And sometimes it is what it is. It's very shallow ground, or it's consistently waterlogged, you can't do anything about it. So you need to drop the input rates back, because when you do a budget, you budget for 12 tonne across the whole crop, but you're only going to be growing, say, 4 tonne there. So put enough nutrients down the tube to grow a 4 tonne crop in those areas. Look, one of the things that I've noticed, particularly looking at yield maps, are one of the main drivers for yield potential or things that are limited production is water. So either too much water or too little water. Sometimes you do start to see some nutrient variations, but it is primarily it's water, which there's a number of factors, that's soil type and drainage and whole things that come into play there. So I think that, in terms of investment, I think one of the best things you could do is probably start looking at these yield maps and start to target these areas, and most of the time it's going to be looking at sort of water, so VRO technology, drainage and a whole raft of things like that. So look, I'm probably going to run out of time, but in terms of advancement, things are, as Tim said, things are rapidly advancing, and it's going to be down the track when we have on-the-go sensors which are going to be controlling VRO equipment. So it's all going to be happening for us as we're driving our tractors or spreaders or sprayers. So look, I'll finish up here because it's pretty hard for me to read those take-home messages when I did the slide, but it's an exciting time at the moment in the precision ag space, and I think that if you want to get into this variable rate application space, you can start off simply, and then you can start, as the technology comes out, you can start to adopting and start, once you're comfortable with it, start taking on more and more. So thank you.